Hi everyone, I just wanted to kind of give a little bit of piece of advice and help you work through how do you calculate a couple of things that are really important for this problem set, which is our peak collar force, PK force, and, as this tries to update, and our resolved shear stress. So if we remember, our peak collar force, PK, is equal to our stress dot our Burgers vector cross with our tangent vector. And then our resolved shear stress, on the other hand, we're going to need to know what is our, basically, our normal vector and what is our Burgers vector. So we need to use our Schmidt resolution temperature. So alpha ij is going to be equal to 1/2 of bi vector and j vector plus bj vector and I vector. And our resolved shear stress is just going to be the product of all of those, alpha ij, sigma ij. So we already have this built into our Mathematica notebook. So let's actually kind of see how we could, in general, work it. So actually, let's look at our problem set right here. So I'm working with a cube of vanadium, and I've applied the following stress state as seen below. So this complex stress state as well. We're not going to solve it for this problem. You could do that from a problem set. So let's say that we apply some just generic stress. So sigma 1,1, sigma 1,2, sigma 1,3, oops, excuse me, sigma 1,2, sigma 2,2, sigma 2,3, sigma 1,3, sigma 2,3, sigma 3,3. So let's just say we apply some generic stress state, and here on our system. So this is going to be the stress that we apply. Now the stress can also be the stress from another dislocation, just as we kind of seen previously in our lecture notes. Now, in this problem, we're given a Burgers vector here. This is our Burgers vector, direction 1, 1, 1. So Burgers vector is equal to 1, 1, 1. And we're given essentially our Burgers vector in the direction of this plane. That will be equal to so it's in this plane, so our normal is equal to 1, 1, 0. There you go. So that's our normal, that's our Burgers vector. Now we can go about calculating all the rest of these values here. Now, one of the things that we're not told in this particular problem is we're not given the tangent vector. So let's just say that we want to make sure that our tangent vector, let's say that this dislocation Burgers vector here, let's just give it a tangent vector that's equal to, actually, let's go ahead and we could kind of rewrite this problem. So forget about, because we don't want to do it exactly like the problem set. So let's say I'm given a Burgers vector, not like this, but so I'm applying a generic stress state here. My tangent vector is going to be in the 0, 0, 1 direction. My Burgers vector is going to be equal to the, basically here, the 1, 0, 0 direction, and let's say my normal, and we have the handy relationship that my normal is just going to be T cross B over magnitude of T cross B. So let's calculate our normal. So I'm going to pull up my my notebook here, and actually before we do that, let's just go ahead and say my T1 is equal to 0, 0. Let me bring it up. 0, 0. This is the notebook that we posted on our class website. B1 is going to be equal to, let's just call it 1, 0, 0. And let's say my N1 is going to be equal to cross T1, B1. And there we go. So it's in that plane, makes sense. So that's my N1, T1, B1. Fantastic. So I can go ahead and calculate, if I have this Burgers vector with this tangent vector in that normal plane, I could calculate what is the peak collar force for this generic stress tensor to be applied here. And the stress tensor can change depending on the stress state here. But again, I'm just trying to show you the general approach. So I could actually calculate that peak collar force here. So I'm going to actually bring this guy down, because I know below here in our notebook, below all the pretty pictures, we actually have kind of our generic stress state. Let's actually go ahead. Actually, we could do this ourselves, but let's see if we have it. Here we go. So for example, this was our T1, B1, N1, And you can see this is just my generic stress rate sig. So if I want to calculate my Peach-Koehler force, sig.b cross t, so sig dot b1, I'm going to cross that with t1. And you see, so those are my components. So this is in the 1 direction, 2 direction, 3 direction, or x, y, and z direction. So you see I have some stress that's in the x direction, some stress in the, or some force in the y direction, and no stress out in the z direction for this. Again, depending on my b1 and t1 values, that can change. So that would be my Peach-Koehler force vector, because force is a vector quantity. Now, let's say I was asked to find out the resolved shear stress. Well, I can go ahead and grab that. So I have that nice function for my resolved shear stress, my alpha. So I can pull that up here. So if I wanted to calculate, so I need to figure out first my Schmidt resolution tensor. So that's my alpha. So B1, you can call that N1, N1. And that'll give me my alpha value right here. So those are the value that I'm given. So B1, N1, again, is the same expression that we're looking at here. Effectively. Here, let's go ahead and show it here. Actually, we could show our other values as well. So you can see this is my FPK is cross sig.b or sig.b1 and then crossed my Schmidt resolution temperature alpha. We'll call it alpha ij. Alpha ij is just going to be a half b1 I times, or basically b1 times n1. And then nj, and then we can go ahead and get those values. And finally, that would be my tau. And so you see I have, my tau is an ij, so I'm just multiplying those values. And then now, my tau, which I'll go ahead and grab that all the way down here, Schmidt resolution tensor, and I could go ahead and get this. This will always be that total. So the alpha ij, or the total your Schmidt resolution tensor, is just going to be this. So the flatten alpha dot sig, and it's just going to be sigma 1, 2. That's it. So those are the values that you're going to utilize for this course. So yeah, that's pretty much how you do it. And this is just, again, a general example. So I hope this helps for, again, calculating your Peach-Koehler force, your Schmidt resolution tensor right here, and then finally your resolved shear stress tau. So let me know. Hopefully this answers all your questions, and excellent. Have a good one. Thanks. Bye.